Hello friends, today we are going to discuss this Codeforces Round 889. We are going to discuss four problem A, B, C1, C2 both. Okay, so we are going line by line. Okay, so first question is Dalton the teacher. So basically I hope you have all read the problem statement. We are just going directly to the solution part. So basically what problem says that we have given basically an array. We have basically given an array. Okay, let's say 3 2 1 4. It is a size of 4. Okay, so now what we want, basically if this is an array of a student, like this is a student 3, this is student 2, this is student 1, and this is a student 4. Okay, and this is seat number 1, this is seat number 2, this is seat number 3, and this is seat number 4. If a student is sitting on the seat, like if the student is sitting on the seat which have equal number to itself, let's say if a student 4 is sitting on the seat number 4, then the student will be unhappy. Okay, and like just like in this case, student 2 is sitting on the student on the seat number 2, it is unhappy. Student 4 is sitting on the seat number 4, he is unhappy. Okay, so if this is the case, then we can say that two students are unhappy. Okay, like this student number 3 is sitting on 1, and the student number 1 is sitting on the 3. So I can say these both students are happy. Okay, so now what we want to make all student happy in minimum numbers of move, in minimum number of operation, all student happy as a this like this. So yeah, so what we want, basically we want all student to needed to be happy, right? So if we try to observe that, let's see, and what operation we have, firstly we have to see what operation we can do. Let's say I can, in one operation I can swap two element. In a one operation I can swap two elements. Okay, two elements, right? So in one operation I can swap it. So let's say if I have an array 3 1 2 4, so how many elements are, so how many elements are not in there, like how many elements are unhappy? Let's say 3 is unhappy because like 4 is unhappy, and who is one more unhappy? 3 is happy, 1 is happy, 2 is happy, only 4 is unhappy. Okay, only the 4 the person is unhappy, right? So he need to swap from at least one, he need at least one swap to be happy. He can just swap it with the, let's say 2. So if it swap it with, let's say 2, then the student will be like 3 4 2 1, and you can see that now all students are happy. Okay, now all students are happy. Okay, and let's say if two students are sitting, let's say if two students are sitting on their position, how many swaps are required? I required one swap. Okay, let's say if there is seat 1 2 and two students are sitting sitting on, like this is seat number 1, and this is seat number 2, and this is student number 1, this is student number 2. Like they both are unhappy, so I need two swaps, right? For if n is even, if n is even, so what we get from this, if n is even, we need n by 2 swap. Let's say if 4 students are happy, sorry, if 4 students are unhappy, if 4 students are unhappy, what we can do, we can just swap, like let's say like 1 2 3 4, let's say they both are unhappy, right? What we can just do, we can just swap these two, and we can swap these two. How many operation we required? We required only 2 operations. So for n we required n by 2 operations, right? And for if n is odd, what we required, n by 2 plus 1 operation. Let's say why, let's say this is the observation which I got, and how I got, like from the first example which I have given, and we can take one more example. Let's say it is 1 2 3 4, and 1 is sitting in its position, 3 2 4, sorry, 3 4 and 2. Like these three students are unhappy, and now what are the minimum step I can perform? I can just simply swap these first. uh, I think, okay, sorry, I messed up here. Sorry. So basically, I have, if a student 1 2 3 4, and if the students, if odd number of students are unhappy, so I have to make a one test case. Like if three students are unhappy, they are sitting. Okay. For making three students unhappy, I have to take a 5. So let's say one. Okay. Let's say 1 2. Give me a second. Let's say these are the seat numbers, and these are the seat numbers. Then and student 1 is sitting on student seat number 1, student 2 is sitting on seat number 2, and student 3 is sitting on seat number 3. And these both are happy because they don't have a same seat number. Okay. So how many swaps are required? I can just swap this. It is will be 2, it will become 2 1, and I can then swap this. It will become 2 3 1 5 4. Now you can see all students are happy because they are not sitting on the seat number which is their number. Okay. So for n mod 2 equals to 1, I required n by 2 plus 1 operation. Or I can just simply say that I want the seal value of n by 2. Okay. So this is my answer. So this is my first solution. I hope you have understood this. If you still if you still have any doubt, you can ask me on the comment section. And let's see, I will show you my code. Like just a simple, if n is odd, and if n is odd, the answer is count by 2 plus 1, and if n is even, just simply count by 2. Nothing else, nothing hard and fast. So guys, now we are going to discuss the second problem of this round. Let's see the problem. So the problem says that we have given a number n. We have given a number n, and we have to tell a sequence size, a larger sequence size, in which, let's say this is a sequence x plus 1, x plus 2, and so on. We have to tell the largest sequence size in which all the elements are divisible by n. Let's say this is a sequence, then n mod x should be equals to 0, and mod x plus 1 x plus 1 should be equals to 0, and so on. Okay. So this is the problem. So basically the problem says that n should be divisible by the all the number in this sequence, and we have to tell the size of this sequence, and we have to maximize this size. What we have to do? We have to maximize this size. So this is our problem statement. Okay. So now we are going to see the solution. So basically, first we have to try to think. Let's say, if I will say, like I will first tell you the statement, then I will show you the solution. Let's say if I am saying that my number is not divisible by 3, if my number mod 3 not equals to 0, if I am saying that if my number is not divisible by 3, what does it mean? Its answer for this solution is can't be greater than, for this the solution can't be greater than equals to 3. Its solution can't be greater than equals to 3. Why I'm saying that? Let's see. I'm saying that if this is the case, if n mod 3 not equals to 0 is the case, what does it means? That it means that my solution is either 1 or either 2. It means that my size of the sequence is either 1, either size of the sequence is either 2. Okay. Why I'm saying like this? Let's say if I am saying that if my number is not divisible by 3, and let's say not divisible by 3, and let's say I have this sequence. Okay. and so on. And if I'm saying that if n mod 3 is not equal to 0, what does it mean? If I take and if my solution is less than is always less than 3. Why I'm saying like this? Let's say if I'm taking any sequence which is of size 3. Let's say take this, either take this, either take this, any sequence. What you will find what you will find one thing in every sequence, that every sequence will contain one element which have a 3 inside in it. Let's say if I am taking this element, it have a 3 inside in it. If I am taking this sequence, it have a 3 inside in it. So basically, if I am taking any sequence with with three numbers with of size 3, if I am taking any sequence of size 3, it will contain one 3 always. Let's say if I am taking this element 9 containing 3. If I am taking 9, 10, 11, also 9 is there. So basically, if I am taking any sequence of size, if I am taking any sequence of size equals to like greater than equals to 3, then what does it mean? It will always contain 3. And what was my first statement? My first statement that was that if n mod 3 not equals to 0, then my solution is less than is always less than 3, which is satisfied. That I can't take any sequence which is greater than 3 or equals to 3. Okay, so I have proved that, like, if you are get like taking any sequence, you are going to get 3. I hope this is clear to you. Similarly, if my n is not divisible by 4, if not divisible by 4, I can say that if my element is not divisible by 4, I can say that my answer is going to be less than equals to 4. Sorry, not my answer is always less not equals to less than 4. Why I am saying this? Similarly, if I am taking any sequence, let's say randomly 9, 10, 11, 12. If I am taking this sequence will contain any element which is a multiple of 4, meaning which contain 4 inside it. Let's say 12, which is containing 4 inside is 4 into 3 is 12, right? So if I am saying this and mod 4 is not equals to 0, it means that my solution is always going to be less than 4. I hope this is clear to you. So what I am going to do, so I hope like there is an intuition behind this problem is clear. If I am taking if I am saying for any element x, if any element x is not equals to 0, then my solution can't never be greater than x. My solution is going less than, always is going to be less than x, right? This is my solution, like intuition. I hope this intuition is clear to you. If there is any doubt, you can ask me on comment section, and I will try to make it clear. And let's see what we can do. We can generalize this intuition. What I can just do, I can just divide n with 1. Check this. If it is divisible, then it means that our solution can be greater than equals to 1. Our solution can be 1. If n mod 2 is equals to 0, well, it is divisible, so my solution can be 2. If my n mod 3 is 0, solution the solution size of solution can be 3. And I am going like my solution can be 1, my solution can be 2. What I'm going to do, I'm just trying to iterate for 1, 2, 3 up to n plus 1. Okay, let's say if for any x I am getting, if for any x I am getting, if I am getting not equals to 0, what does it mean? It means that my solution will be x minus 1, because for every x minus 1, I have checked that every x minus 1 is divisible by n. So our answer will be x minus 1. So this is the x minus 1 is the maximum size. I hope this is clear to you, and we will just see the code now. Code is simple, as I explained that I have run a for loop, and if it's n mod I if is n mod I equals to 0, it means that if n mod I equals to 0, it means that it is divisible, so we are not going to the loop. If n mod I equal to something else other than 0, it means that it is not divisible, and we just print I minus 1 and we just break it. I hope this is clear to you. Now we are moving to our third problem, which is dual easy version. Okay, let's go. Let's see this problem now. Okay, so basically the problem says that you are given an array of an integer, positive, negative, or zero. You can perform multiple operation on the array. In one operation, you choose ij and set a of I equals to a of I plus j. Make an array non-decreasing in most 50 operation. So basically, what question says, we have given an array. We have given an array, right? Let's say 2, 3, 5, 5, 1, 1. Just say search. Okay, let's say I'm just doing it again. Let's say I have an array 2, 3, 5, 1, 4, and 4. Okay, so this is the array. So now the thing is, uh, it can be also contain negative element also. So what I want this array as a increasing order array. Okay, or I can say I have to make this array non-decreasing. Okay, and I can perform operation like a of I equals to a of I plus a of j. I can basically, what does the operation means that I can add any element from the array to that particular element. Okay, like I found this problem very like interesting, like because this problem, if you have to solve both the version of this problem, like c1 and c2, you have to think like very calculative, like you have to be very accurate about your, like for every test case you need to be very accurate. You can't just go with the like go with your intuition. If you want to solve the like for problem c2, you have to be need to be very accurate about your solution. So let's see what the like what we can do. So we can have a first a few observation like that. If I have only positive element, let's say 2, 3, 1, 5, 4. If I have only positive element, I can see a one observation that my first observation is that I can just simply make it increasing by just taking a prefix sum. Okay, what is prefix sum? I will add this in this. It will be 2. I'm just doing what the problem says, that in this I have what I have done, a2 equals to a2 plus a1. Okay, um, a2 plus a1, and after getting this 5, I will just add this 5 into 1, get a 6. After getting this is, I will just add this is into 5, I get 11. After getting this 11, I will just add it to 4, I will get 15. After getting this 15, I will just add it to 6 and I will get 21. Okay, so what you will see that now this is an increasing. So basically, if my every element from this observation, what I can see, if my every element is positive, I can just simply solve this problem in n minus 1 steps. Okay, I can just simply solve this problem in n minus 1 steps. And the first problem says that I have to solve this question in less than 50 steps. Okay, less than 50 steps I have to solve this, less than equals to 50 steps I have to solve this problem. And what is the maximum value of n? And the maximum value of n will be 20 only. So if all elements are positive, we can just simply solve this in 19 steps. Okay. Similarly, for negative elements, if all elements are sorry, if all elements are negative, we can just simply solve it in n minus 1 step. How? But by just taking a postfix sum. Let's say -1, -2, -3, -4. We can just simply solve this. Okay, give me a second. I just to plug the charger. So if I just take like, we know that if I am just we can't take prefix sum in this, because in prefix sum what we are doing, we are just adding an element, and adding a negative elements means decreasing an element. So basically what we are going to this, in this we are just going to take a postfix. So basically if I have a 4, if I adding any element, any negative element to this, I am going to get the I can say the smaller number, because I am just decreasing it. -4, -3, -7, -7, -2, -9, -9, -1, -10. And if you see, this is an increasing array. So we have C2 observation for all positive element in the array, and for all the negative element in the array, we just need n minus 1 operations. Okay. Also it can include 0 also. Like if I have all positive element with few zeros, we can also like if I have 1, 2, 0, 0, 3, 4, and like for this n minus 1 is going to work, because like if I'm just going to take prefix sum of it, it will be like 1, 3, 3, 3, 3, 6, 10. So it is also an increasing array. So if I have a 0 also, it will not affect anything. Similarly in negative, I have a 0 also, it not going to uh, like affect -2, -3, -3, and -3, and it is an increasing array, right? Or I can say a non-decreasing array. So what we have gave a few like two observation. Okay. So now what case if I have a positive and negative element both? Now we have to see the solution for this case if I have a positive and negative element both. Okay. So what for this? Okay. So let's say I have an array which contain positive as well as negative element. So I got, like when I was doing a problem, I got an intuition. Why not if I have a positive element, right? And there was one more constraint. Another constraint was that the maximum value of maximum value of array will be 20, and the minimum value of the array can be 20. So like the array will contain only 20 elements, and its range will be from -20 to 20 only. From this I got one observation that if I just make any element, like if I make the largest element of the array to 20, if I make largest element array to 20, let's say if I have 1, if I somehow make it 20, right? If somehow make it 20, and and what I will do, and if I make every negative element, let's say if I have 1 in an array and it contain negative elements. Okay, so if I somehow make 1 to 20, let's say it, if I make 1 to 20 in x steps, okay, and let it can like, if not one, let's say it is a y. If I am making y to 20 or greater than 20 or greater than 20 in next step, now what I can just simply do, what is the minimum element I have in an array? Can we have in I can have only minus 20 in array. I make like y is to be increasing like greater than equals 20, and now I can make every negative element to positive in a single step. Let's say if I have a 19 negative elements, okay, if I have a 19 negative elements and one positive element, I will make this one positive element greater than equals to 20. Okay, and how many steps I have required for to this make it uh, greater than like we will see it after. Like how many steps I have required to this make negative element to positive? I required only 19 steps. So now, what I after performing this 19 operations maximum, I am just seeing the worst case for now. After I have an array which contain all the element as a positive, what I am going to do, I am going to add this number which is 20 greater than 20 to every negative element, and my negative element can't be greater than like can't be less than minus 20, so it will be on one operation, and for 19 negative elements it will be maximum 19 maximum 19 operations. I hope this is clear to you. So for 19 operation, and after doing this 19 operation, I can just simply do n minus 1 operations, right? And I have performed also x operation to make that element greater than equals to 20. So my maximum value of n is 20, so it will be 19 plus 19 plus and x. And what is the value of x? It will be 38 plus x. Let's say if I have a 1, let's say like I have a 1 pause, but I have to make it 20 or greater than 20. What I can just do, I can just simply add 1 plus 1, then it will become 2. Then I will add 2 plus 2, then it will become 4. Then I will add 4 plus 4, then it will become 8. Then I will add 8 plus 8, it will become 16. Then I will add 16 plus 60, it will become 32. So I make the number which is greater than 32. So how many steps are required? 1, 2, 3, 4, 5. So if I have the minimum, if I can make any element, I can make any element greater than equals to 20 in only 5 steps. I can make any element greater than equals to 20 in, like if I have a 5 or I can say 6, I can make it greater than equals to in less than 5 steps. Okay, less than equal to 5 steps. Okay, so how many operation I have performed? 38 plus 5. 30, what is 38 plus 5? 35 plus 43. So basically I can solve every problem in 43 steps. I don't even require 50 steps. I don't even require 50 steps. I can solve every problem in 50 steps. What was my approach? I make one positive element to greater than equals to 20 in, let's say, in worst case in 5 steps, and after making this element 20, I make every element positive. Let's say I have 19 element as negative. I'm taking the worst case because I can have max 20 element, right? And I have one positive element and every element is negative. If every element is negative, I need 19 steps. And after doing this, if I have my value of n is 2, which is like worst case, I need 19 steps. So basically 19 plus 90 plus 43. So after doing in just 43 step, I can solve every problem. I can solve every problem in 43 step. And how many steps we have required? We have required only 50 steps. Okay, so we have solved this problem C1. We have solved the C1 problem in less than 50 steps. This was a C1 problem. And this now we are going to see the C2 problem. So basically what C2 problem was similar to C1, just except one thing. The thing was that C1 problem have a less constraint, that now we have to solve this problem in less than equals to 31 steps. I think 31 was uh, the case. I just have to see that first. So I think 31 was the case. Yeah. I have to see, I have to now I have to solve this problem is less than 31 steps. My first problem was I have to solve this less than 50 step, and we have proved that here I can solve every problem in 43 steps. Now what we want to prove, we have to prove that we can solve this problem in 31 steps also. That that is the only thing we have to now prove. Okay. So to solve this problem, uh, we have to see few more like we have to like nothing, we have to think nothing else. We just have to use our previous observation and just calculate the things which is present uh, in the array. So let's say what is given, that I have 31 operation. Okay, now my, let's say my n value is 20, which is the worst case. Okay, so let's say my n, now I have contained an array which will contain positive as well as which contain negative elements. Negative elements mix. Okay, so my approach is going to be same. I'm just trying to make, I want this array to be fully negative, or I have to make this array which contain only negative or only positive elements. Okay, if I do something like this, so how many steps I have required, like after this, if I have make every element positive, or if I have make every element negative, I required, then I after it I required maximum 19 steps. I have showed you earlier. If my every element is positive or every element is negative, I require n minus 1 step, and for n equals to 20, my steps are 19. Okay. So in 31 test cases, in a 31, for the worst case, I have required 19 steps. So how many steps remains? 12 steps I have remained. So now my what the challenge is? The challenge is I have to make every element either positive, either negative in only 12 steps. In only 12 steps. What I have to do? I have to make every element either positive, either negative in 12 steps. I hope this is clear up to now. If you have still any doubt, you can ask me in comment section. I will make you clear. I will try to make you clear. So I have now, what I was saying, I have to make every element positive, either negative in an array in a 12 steps. Okay, let's say I have an array which contain positive as well as negative element. Now if I have a positive element whose absolute value is greater than negative element, I will try to make now cases. If I have positive element whose absolute value is greater than negative element, what does it means? That I have 20 and I have 20 as, I can have only 20 as a like maximum positive element, and my negative value is minus 20 is greater than equals to, if my positive element is greater than equals to absolute of negative, okay, then what I can just do, if if I have an array, okay, let's say it contains 20 elements, it contains 20 elements, okay, it contains 20 elements. So how many steps I have remain? I have remain only 12 steps. Okay. So if there is a case I have 12 negative element or less than 12 negative element, I can just simply do that. I have 7 positive element, I have 7 positive element and I have 12 negative element. I can solve this. What I will just do, I will just do by using my by using my 12 operation, I will make all 12 element negative to positive. If I have less than 12 element negative element less than 12, I can just simply do this because I have maximum. I have maximum 12 operation. If I have an 11 negative element, if I have a 10 negative element, I can just do this. Now, if there is a case, hey, you say like, hey, Bharat, if there is a case, I have more than 12 negative element. So what you will do in this case? What you are going to do in this case? If I have, let's say, 13 negative elements. So if I just try to make every element positive, okay, give me a second, it shrinks. Okay, if I have 13 negative elements, hey Bharat, so how will you going to solve this? Because I have only 12 steps remains because I have decided that I am going to use 19 steps for for solving that n minus 1, like for the performing that n minus 1 operation. So how you are going to solve this 13 in 13 steps? Okay, so in that case, what I will say you, now I am not going to make every element positive, I will try to make every element negative. Okay, now what I have discussed in the previous case, I have discussed that now I am taking a case, I have greater than 12 element negative. I have greater than 12 element negative. Okay, it is not clear. I have greater than negative elements are greater than 12. Okay, so what does it mean? I have positive element less than 7. I can say that, like, because if it is greater than 12, so it will be 13, and it will be 13 and my positive element will be less than equal to 7 because maximum value of n is 20. Okay, so what I will try to do, I will try to do every element, make every element negative. Can I make it? So let's say I have like I have show you like in our first example that I have like explaining first example that for any element, what I need, if I have to make that element greater than 20, if I have to make that element greater than 20, what I have to do, I have to perform at max 5 operation. What I have to perform at max 5 operation, I have explained you. I have if I have a make element greater than 20, I have to at max perform 5 operation. I have explained you earlier. Okay, so if I have to make any element, I will say any element less than 20, because if I have a positive 20, so if I have to make, so if I have to make any element less than minus 20, or like it will be less than, let's say I have to make any element less than minus 20, it will be minus 30, I have to make minus 21, minus 22, then also I required only 5 steps. How? Let's say I have minus 1 and I have to make this smaller than minus 20. So minus 1 plus minus 1, it will be minus 2. Similarly, I'm going to do like similar thing, nothing else, minus 4. And similarly, at some point of time, minus 16 plus minus 16 will be minus 32. So how many steps required for this? So I have required 5, it required 5 steps for this. Okay, so I can make any element negative like less than 20 in 5 steps. So how many steps remains? In 12 steps, I tried make I tried make any element. I tried make any element as like less than 20, less than, sorry, minus 20. So it requires me 5 steps. So how many steps remains? 7 steps are remain. Now now in this case, like told you, I have 13 negative element and 7 positive element, right? Okay, if I have 13 negative element and 7 positive element, I have 7 step remains. I can just simply make this 7 positive element to negative element in one steps, because I have the greatest element. So basically I have the smallest element, not greatest, greatest in negative. I have small, let I have minus 32 in 5 steps. If I have a minus one, right? Like if I have a something else, I can make it, I mean, like less than minus 22, sorry, minus 20 in less than 5 steps. So if I have, in worst case, if I have performed 5 steps, I have remained with since 7 step, I can just simply convert this 7 positive element with within 7 step. So like this problem was made in a, like in a case that this problem is only solved, can be solved in 31 step. Similarly, you can do all this thing for negative element also. First of all, what I will do, I will try to make every element negative. And if I have one case that if I have negative element, if I have to make, if I have a positive elements less than equals to 12, because I have remained 12 step, I can just simply do this. If there is a case, if I have a positive element greater than equals to greater than 12, let's say I have 13 element, what does it means? It means that I have 7 negative element or less negative elements. Similarly, what I will do, I will try to make positive element to the largest than 20. I can just make it in 5 steps. How many steps I have remain? 7 step, and I can simply convert, using this 7 step, I can simply convert this negative element, all this negative element to positive element in 1 steps. Huh. I hope this is clear to you. I have explained this 2 times. If you have still in doubt, you can just start seeing this video again. You have a clear, you have a clear thought about what is going. So now I'm going to show you my code. I think if you see my code, it will be more clear to you. So what I just did, I just run a for loop, and what I just did, I run a for loop, and I have just counted a positive element, I just counted negative element, and I just counted zeros also. Similar, like I solved like this. And my first condition is if my count plus count 3 equals to n, it means that if I have only positive element, I can also have like if I have only positive element with zeros, then I just simply do what I'm going to just do. I'm going to simply perform n minus one operation, which was prefix sum, like adding a2, like adding a1 into a2. Then after doing it, adding a2 into a3. After doing this, adding a4, a3 into a4, and so on, and it will be n minus one. Okay. Similarly, if I have all negative elements, including zeros, then similarly I am going to perform a postfix sum, and I am just going to add n minus one to n minus two, and after doing this, I am going to add my n minus two to n minus three. Similarly, and this is my solution. Now there is a main case arrived that I have contained all positive element on all negative element. Then what I just find a maximum element. I found minimum element. If my maximum element is greater than my absolute or minimum element I have explained you, then what I am going to do, I am going to check if I have negative elements. So what I will try to make, if my positive element is greater than the absolute value of absolute value of negative, so what I will try to do, I will try to make every element positive. Okay. So if my, so as you know, I have remained only 12 steps. So if in a, like if I have only uh, only negative element remaining, I have only 12 elements remaining, then I can simply make that 12 element to positive in a 12 steps. But if there is a case I have more than 12 elements, I have more than 12 elements, uh, I have more than 12 elements negative. What I will try to do, I will try to make every element as negative. So for what, so to do this, I just try to make a number which is greater than minus 20. Okay, not greater, it will be, I guess, less than. Okay, no problem. So what I'm going to do, I'm just going to make like minus 30 or minus 40, right? I'm just trying to do this. After making it, after doing this, I'm just going to perform similarly. Uh, like I have to perform only 7 operation to make it positive, and I have 19 orbs like operation reserved for all the negative elements. Okay, similarly, I have done this for the positive negative elements. If I have negative elements, and if the count of positive element is less than 12, then this is going to happen. If count is greater than 12, then this is going to happen. And I just simply printed my solution. I hope this is clear to you, and if still is there any doubt, you can ask me in comment section. I will try to make you clear. Thank you.